This is an instructional video on scatter plots. When talking about scatter plots, we want to recognize that there are three types of association. The first type is a positive association. A positive association is when the points go up. So on the graph, the points are going up. A negative association is when the points are going down. The third type of association is no association, no relationship. And that means that the points are random. They're just scattered all over the place. Now, when we're talking about the points going up, down, or being random, what that means is that the variables, what we're talking about on the graph, is what is changing. So for a positive association, the points are going up. It means that both variables are going up. For example, I could say the more you study, the higher your grade is going to be. Both of those are increasing. The more you study, that's increasing. The higher the grade's going to be. That is also increasing. For a negative association, when the points are going down, it means that one variable goes up and one goes down. An example would be the more TV you watch, the lower your grade on your test is going to be. So one variable is going up. The more TV you watch, that's going up. The lower your grade's going to be. That one is going down. And then no association, where the points are random, it's when the variables don't relate. For example, the number of books you read and the number of pets you have. There is nothing that states that people that read more have more pets. Those two variables do not go together. So that would be a no association. After that, we have just a couple of key points of vocabulary that we need to go over. The first vocabulary term, and we've already learned it, is the word linear. Linear means it's going to be in a straight line. The other term, nonlinear, means not a straight line. We could say that a scatter plot is strong. That means that the points are close together. We could also say that the scatter plot is weak, meaning the points are far apart. Sometimes we call a point an outlier. An outlier is separate from the rest of the group. That one point is separate from the other points. It doesn't fit in the pattern. We also have a cluster, which is called a group of points. And the last word is called a trend line. And it's a line that goes through the middle of the scatter plot. All of these terminologies are words that we can use to describe what is happening in the scatter plot. And we're going to use these vocabulary terms to answer our practice problems in this video. For this problem, we have 6 scatter plots, and we're going to label each type of association, the strength of the association, and whether or not it's linear. So for the first part, we're going to label the type of association. So is it positive, negative, or no association? For problem number 1, my graph and points start at the bottom and move towards the top of the graph. So that would be a positive association. In number 2, the dots again start near the bottom and go towards the top of the graph. So that one is also a positive association. Number 3, the points start at the top and start at the bottom and go towards the top, which is a positive association. Number 4, the points start at the top of the graph and then move towards the bottom. That is representative of a negative association. Number 5, again, that first point is up at the top, the last point is near the bottom, so that one is also a negative association. And then the last graph, I can't draw a line through those points because those points are random, so that would be no association. Now, for the next terminology, we're going to talk about the strength of the association. A scatter plot can be either strong or weak. A strong scatter plot is when the points are close together. In number 1, those points are close together, so that would be a strong positive association. In number 2, the points are farther apart, so that is a weak association. In number 3, again, the points are back to being close together, so that one is a strong association. In number 4, the points are again still close together, so that is a strong association. In number 5, the points are far apart, so that is a weak association. And again, in number 6, there's no association, so it's not strong, it's not weak, it's just nothing. The last section asks us to decide whether the graph is linear or not. Remember, linear means straight line, nonlinear means not a straight line. In number 1, I have a straight line running through the middle of my graph, so that one is linear. Even though the points don't form a straight line, they are close to being in a straight line format. Number 2 is also linear because I drew a straight line going through the middle of the points. Number 3 is nonlinear because you can see that my points start to curve towards the top of the graph. Number 4 is a linear association because the points are relatively moving in a straight line. Number 5 is nonlinear because the points start to curve there in the middle of the graph. And again, 6 is no association, so it's not linear or nonlinear. Those points are completely random. So for this problem, we're looking at 2 different variables, and we want to decide what type of association that variable has. A positive association, a negative association, or a no association. So, looking at the first one, we have a person's height. So that means the taller a person is, so it's going up, the taller a person is, the larger their shoe size. Both of those variables go up in that scenario because typically a tall person has a large foot and a small person has a smaller foot. So the taller the person, the larger their shoe size. That is a positive association. For the second one, we have the number of letters in a person's name. So that would be the more letters in the person's name, the higher the IQ. Now, these two don't go together. It does not matter how many letters are in your name, whether your first name has 4 letters or 12 letters. That does not decide your IQ. IQ is intelligence. The letters in your name do not determine how smart you are. That would be a no association. And the last one, the number of absences a student has. So the more absences they have, the lower the GPA. Typically, when you are absent from school, your grade goes down because you have missing work. So one of the variables is going up, your absences is increasing, your grade is decreasing. That is a negative association. So in these examples, we have 3 scatter plots and we have 3 types of variables. And we are going to match the variables with the graph. So starting with letter A, it says the temperature outside and the total gallons of gas sold at a gas station. Letter B, the size of a home and the cost of monthly utilities for the home. And C, the altitude of a hiker and the total oxygen level in the air. So starting with letter A, if the temperature outside is increasing, so that means it's getting hotter, then what happens to gas at a gas station? Well, gas stations don't care about how hot it is outside. They sell gas in the winter and the summer and the spring and the fall. So that would be a no association, which would be representative of number 10 because those points are scattered randomly across the graph. Looking at letter B, it says the size of a home and the cost of monthly utilities for the home. So if the home is increasing in size, so a big home, then it's going to be more expensive. Cost is talking about money, so a bigger home is going to cost more. Both of those are going up, so that is a positive association. A positive association is number 9. Because those points move in an upward trend, which is representative of letter B. And the last one, letter C, the altitude of a hiker and the total oxygen level in the air. The higher the hiker climbs, so the higher he goes up the mountain, the lower oxygen he has. He has less oxygen the higher he is. That is a negative association, which is represented by number 8 because the points are going down. Mrs. Dominic's class did a survey about the number of chores students did and the amount of allowance that student earned. Brian thinks that the association is negative because they found that as the number of chores decreased, the amount of allowance also decreased. Is Brian correct? Explain. So if chores is decreasing, and allowance is decreasing, we could say that their data is correct. It makes sense. The less chores that you do, the less money you're going to get. However, Brian is incorrect because a negative association is when one variable goes up and the other goes down. If both of them are going down in this instance, that is a positive association. And I know what you're thinking. How is that possible? Well, we could turn these variables the other direction. I could say that the more chores you do, the more money you're going to make. And so therefore, both of those are now increasing. Both of those are going up. And so that is a positive association. Positive is when they both go up. Negative is when one goes up and the other goes down. For this problem, we're going to use the data in the table to make a scatter plot, and then we're going to answer the questions that follow. So we first need to plot the points. Jared, we're going to go over to 14 and up to 4 and put a point. For Tyrell, we're going to go over to 25 and up to 6 and put a point. For Anthony, we're going to go over to 27 and up to 7 and put a point. For Mark, we're going to go over to 15 and up to 11 and put a point. For CJ, we're going to go over to 26 and up to 6 and put a point. For Kevin, we're going to go over to 16 and up to 13 and put a point. For Wade, we're going to go over to 15 and up to 12 and put a point. For Kyle, we're going to go over to 26 and up to 8 and put a point. For Chris, we're going to go over to 16 and up to 14 and put a point. And for Tim, we're going to go over to 28 and up to 5 and put a point. So for this association, the question asks, what type of association do you see in the scatter plot? List any other observations in the space below. You might think this is a no association and that those points are random, but because there are those groupings, that typically means there is an association. This association is negative. Those points group at the top and then are grouped at the bottom. That is a negative association. List any other observations in the space below. You could say that there are two clusters. There's two groups of points. You could say there is one outlier. That's the one point that's by itself. And you could even say that it's a you could tell if it's a strong or a weak association, or if it's linear or nonlinear. Any of those observations are fine. For this problem, it says, on Tuesday after school, Charlie asked 9 different students how much money they had in their lunch account, as well as how many homework assignments they had that evening. Use the data he collected to make a scatter plot. So again, we're going to graph these points. So we're going to start at 0, and we're going to $8.24. At 2 homework problems, we are at $29.05. With 1 homework problem, we're at $4.75. With 0 homework problems, we are at $20.01. With 3 homework problems, we are at $1.80. With 4 homework problems, we are at $11.92. With 1 homework problem, we are at $0. With 2 homework problems, we are at $17.50. And with 3 homework problems, we are at $26.11. So the first question, describe the association between the variables, and what can we conclude from this? This is a no association because those points are completely random. There's no pattern. And so we can say there is no relationship between homework assignments and your lunch account, which makes sense. Teachers do not care how much money is in your lunch account. We just assign the homework. For part B, are there any outliers? No, because no point is completely by itself. And then is there any clustering? Again, no, because there is no point in a group. There are a couple that are side by side, but they're not in a large group. For this problem, it says the population of 10 cities and the number of elementary schools is shown in the table. So we're going to make the scatter plot from the data. And then we'll answer questions A, B, and C. So for the first city, Lawton, we have a population of 76,000, and we have 19 elementary schools. For Moore City, we have 60,000 people and 17 elementary schools. For the next city, with Lufkin City, we have 35,000 people and 10 elementary schools. For Cheyenne City, we have 73,000 people and 22 elementary schools. For Danville City, we have 51,000 people and 13 elementary schools. For Madeira City, we have 78,000 people and 26 elementary schools. For Weatherford City, we have 25,000 people and 12 elementary schools. For Prosper City, we have 13,000 people and 7 elementary schools. For Glen Falls, we have 20,000 people and 20 elementary schools. And for Dalton City, we have 85,000 people and 21 elementary schools. So now we can answer the questions. Describe any association between the variables, and what conclusions can we make? So just looking quickly, we can tell that these points are typically moving in an upward trend, meaning that is a positive association. Remember, a positive association is when both variables are increasing. So we could say the larger the city, the more elementary schools there are. Both of those are increasing. The larger the city, that's going up. The more elementary schools there are, that's also going up. The second question, are there any outliers in the data? Yes. We could say that Glen Falls is an outlier because it's completely by itself. It is separate from the rest of the scatter plot points. And part C, is there any clustering in the data? I would say no, no clustering, because there are no distinct groups. There are some points that are close together, but no actual groupings. And the last problem, it wants us to write yes or no to describe whether or not the line is a good trend line. So for the first one, this is not a good trend line because it's not following the points. We want the line to run through the middle of the graph. And so we want a line similar to what I have drawn going through the middle of the points. The line that was given is going the opposite direction. Number 2 is a good trend line. That point goes through the middle of most of those scatter plot points. Number 3 is not a good trend line. It's a little bit too high. We want it to go through the middle of the points. And number 4 is also not a good trend line. It's a bit too low. Again, we want it to go through the middle of the scatter plot.